Station devices are exponentially growing in this modern era.
Wi-Fi definitely has a very big role in that. How do you test these devices? To address these questions, I have invited our guest,
Sitarama Penumetsa, CTO at Candela Technologies.
He is now here to talk everything about stations.
And station-side testing.
How did stations evolve? Could you please walk us through that?
20 years ago is a laptop or a desktop machine. And that slowly transitioned to the smartphone era. And then application-specific devices, barcode scanners, wireless printers, asset tracking devices, patient monitors, infusion pumps. So everything runs over Wi-Fi. And if it doesn't work, it creates a lot of problems. Now testing of station devices becomes extremely important.
What is the difference between testing an access point, testing a station device?
When you're testing a Wi-Fi router, we focus on stress and performance, scale, and Wi-Fi protocol features and so on. But when you test a station, it's more about
what are the key metrics that one should consider while testing a station device?
any device that has a radio. We need to make sure that the radio is good.
How do we create a test plan to test all these devices, and what are the kind of test cases that I should include in the test plan?
Right. So I would say
Welcome to Weekly Wi-Fi Wisdom podcast series, where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host, Sainath, QA engineer at Candela Technologies, and over the past few years, I have been testing access points to ensure that it delivers good Wi-Fi experience to the users. It is true that access point plays a very pivotal role in Wi-Fi experience to the users, but that is just only one side of the link. On the other side of the link, you have a device that is connecting to the access point, a client device, or in simple terms, we can call it as station. Now, what is a station device? In very simple terms, any device that has a Wi-Fi radio and connects to an access point can be called as a station device. And it ranges from your mobile phones, laptops, smart TVs, and probably today VR headsets. And I have been researching about the client devices that are present in the industry today, and it's surprising that they just don't confine to the consumer electronics anymore. And if we see the domains, they are into IoT devices, they are into healthcare, and there are devices in industrial applications, and also in the office enterprise applications. So they are spreading, they are growing in number, and according to a report, there is an estimate that over 200 billion devices are connected to internet today. Wi-Fi definitely has a very big role in that. And with this scale and with this variety of devices that are coming online to the internet, I naturally have many questions like, how do you test these devices, and what are the kind of performance metrics that you consider to evaluate the user experience? And to address these questions, today I have invited our guest, Mr. Sitarama Penumetsa, and he is the CTO at Candela Technologies, and he has well over 25 years of experience in Wi-Fi testing.
yeah, glad to be here, Sainath. Happy to share whatever information that I can share. Yeah, absolutely. So
I'd like to understand the fundamental difference between what is the difference between testing an access point and testing a station device. So how do you approach while testing the station device? What makes it different from access point testing?
yeah, so traditionally a Wi-Fi router or an access point, normally we refer to if it's a residential Wi-Fi router, if it's an enterprise, we call it a Wi-Fi access point. So these devices are designed to handle many devices on many stations, and normally they are connected to the power, so they are not battery powered. And normally a Wi-Fi router or an access point is in a fixed location. So and it is expected to handle maybe 50, 100 different types of Wi-Fi devices. So when you test a Wi-Fi router, normally you test it for scale, you test it for throughput, performance, and many other areas. But when it comes to a station, while a Wi-Fi router can have only Wi-Fi interfaces on it, mostly Wi-Fi interfaces, A station device has many interfaces. It has basically a Wi-Fi interface, Zigbee, Bluetooth, cellular interface, GPS, many other radio interfaces on it. And a station device has many other components to it that are different when it comes to a router. So when you're testing a Wi-Fi router, we focus on stress and performance, scale, and testing the Wi-Fi protocol features and so on. But when you test a station, it's more about user experience and usability, and make sure it works and can work well in our various application conditions and so on.
That's interesting to hear because, as you said, access point just sits in a fixed location, but client, well, at least some of the clients, the same might not be the case. They can move around, right? So, what are the key metrics that one should consider while testing a station device? So, if I have to test one particular station device, what are the aspects that I should consider so that it delivers a good user experience?
Yeah, it starts from the basics. Of course, any device that has a radio, we need to make sure that the radio performance is good. So, which means that the main components of a radio are a transmitter and a receiver. So, any signals that you transmit are the transmitter is used for that. When you receive signals, you use the receiver, and you need to make sure your transmitter is functioning properly, and it is following all the specs that are required. It is following the transfer power thresholds that you have, and also if you're transmitting within a band, you need to make sure it's within that band. The transmissions, the RF energy is within the band of transmission. So there are very RF level tests that you need to do when you're testing a transmitter. Same with the receiver. The receiver on a Wi-Fi radio in a station needs to be able to receive many different types of signals at different modulation rates, at different configurations and settings and distances and so on. So you start there by making sure your transmitter and receiver on a station are really good. And then you move on to performance, throughput, basic throughput, and benchmark the performance. So if you're making a Wi-Fi module that goes into a station and it belongs to a particular standard and uses a certain standard, let's say it's 11AC radio or a 11AX radio, we need to make sure that the basic throughput is reached as per the spec. And so you need to do some benchmarking there. And then as you go up the stack, then you're looking at user experience, you're looking at latency, you're looking at mobility, you're looking at battery power, you're looking at tolerance to interference, you're looking at coexistence of multiple radios on the station device. Unlike, as I said, unlike an access point, a station device could have 4 or 5 different radios that are all packed into a very compact form factor. So all these radios are sitting right next to each other. So when they're all operating at the same time, let's say you are maybe having a WhatsApp call on Wi-Fi while you are basically having a normal Zoom meeting or some other conversation on the cellular interface while you're tracking something on using GPS. There are multiple radios on the device that are being used at the same time. So how do they coexist and how do they make sure there is no interference there? All of those things need to be tested from a Wi-Fi point of view.
Yeah, so the complexity could be higher on the station device since multiple interfaces are present on the device, right?
Right.
Yeah, and now I'd like to understand how the stations have evolved over time. So let's say today, probably VR is growing in demand, but if you take 20 years back, uh, nobody thought of VR probably, and the landscape of client devices might look different. So how did stations evolve over time? Could you please walk us through the history and evolution?
Right, absolutely. So the very first Wi-Fi stations that came out are the PCMCA cards, the cards that went into laptops. So the only station that was really used as a Wi-Fi station probably 20 years ago is a laptop or a desktop machine that is trying to connect wirelessly, right? And so you would have this basically a card that inserts into a laptop, and that acts as your Wi-Fi station. So as the technology evolved, then laptops started to have inbuilt Wi-Fi radios in them, so that's built into the system.
Oh.
And then that slowly transitioned to the smartphone era, where you have Wi-Fi built into smartphones, and then tablets came afterwards. And these are all what we refer to as general wireless devices that are used for just like computers basically. And then over a period of time, that evolved into what I refer to as application specific devices. So these are designed for specific applications. So for example, if you take a retail environment, you will see barcode scanners, wireless printers, different types of asset tracking devices and so on. If you look at healthcare environment, you'll see medical equipment, patient monitors, infusion pumps, defibrillators, various types of devices that run on the Wi-Fi network, right? So that.
So are they the devices that you are mentioning about, the application specific devices? So do they have very specific use cases, and don't they do much anything beyond that specific use case?
They do have very specific use cases, and even the kind of equipment that I'm talking about, if you take the example of medical equipment, so you have a patient monitor. Normally when you go to a hospital, you'll see these patient monitors next to the bed,
Right.
and they're reading vital stats. They're reading blood pressure, heart rate, various kinds of stats from the patient, and they are transmitting that information real time to the nurse's station. In the past, it used to use some proprietary wireless technologies before. Now it uses Wi-Fi, because in the hospital you have Wi-Fi everywhere. So now the patient monitor is collecting all the vital stats and transmitting them in real time to the doctor or the nurse's station over Wi-Fi, and that is a very specific application that it is running.
Right.
And this application is mission critical, right? So even if the Wi-Fi connection is dropped for a few seconds, or the client goes to sleep, and you're not able to send critical information to the nurse's station, and if something happens, some incident happens during that time, that could be a life or death scenario.
Absolutely.
Yeah.
Right. Right. Thanks for sharing that insight. And one question regarding the hardware capabilities. So if you look at access points, for example, this box that we have here, it's a latest Wi-Fi 7 router, and if I count the number of antennas on the box, I think it's around 8 antennas that it has. But if you take the mobile client device, for example, my mobile phone, how many antennas does this device generally have? Is it usually high or low? High or low? Why? Why is that?
Right. It's access points are now, again, as we mentioned before, they're supposed to handle many client devices, and they don't have generally a space restriction. You can have if you look at this box, this access point, this Wi-Fi router is pretty huge in size, and it doesn't have any power issues, right? You can connect it to the wall, and you can draw power from the wall. So there's no power issue, there's no space issue. So of course these routers and access points can have many antennas. They can do 4x4 MIMO. Some in rare cases they can do 8x8 MIMO and so on. So and then with technologies like multi-user MIMO and things like that, having more spatial streams and antennas always helps the access points and routers serve multiple devices. But when it comes to a station, you have all these restrictions. You have power restrictions, you have space restrictions. At best, most stations that you see a smartphone usually have a single spatial stream size, so, or maybe two 2x2 MIMO at best. Because that is the space that you have on the device. And remember that we are cramming many radios into this very small form factor. And then it's just not the radios, and there are so many other things that get crammed into a very small form factor. And it's very important to make sure that you don't have these physical issues that are relating to MIMO technology and so on. And frankly speaking, there is really no need for that much bandwidth like what an access point would need. A normal station would do, even if it does a VR application, we are looking at like probably 20-30 megabits per second, maybe 50 megabits per second at best, which can be easily handled by a Wi-Fi radio that has two antennas and two spatial streams.
Right. Understood. And now let's talk about, is it actually important to test station devices these days?
Yes, that's a great question. So as I always believe, testing is always important, and people try to avoid testing as long as they can, until it starts affecting the profitability of the product, and the quality starts affecting the brand and the profitability, right? So if you look at the evolution of station devices, especially these application specific devices, the early versions of Wi-Fi radios that I've seen in consumer electronics, like if you see, let's say, a Wi-Fi radio in a washing machine or a refrigerator, or even in an automobile like a car or something like that, they were mostly there as an attraction point for people to buy the product. They were never really expected to be used. So when I bought one of my early cars in the US, I purchased that car only because it has voice control systems, and it has GPS tracking, and they're all basically connected to each other, and it has all these fancy features, which, by the way, I've never used in the entire time that I had my car, but it actually was the reason why I bought it, right? So if you look at how Wi-Fi evolved in these application specific devices, it was more as like a nice to have feature. I mean, if you go to a electronics store and you see an air conditioner and it says Wi-Fi enabled, and you see an air conditioner that doesn't say Wi-Fi enabled, you would most likely buy the air conditioner that says Wi-Fi enabled, right? So that's what happened. So the early versions of these stations really had the Wi-Fi modules there only for marketing reasons, and so they never really tested them. So what they would do is, let's say a company is making an air conditioner, and wireless and connectivity is not their expertise. So what they would do is they would actually buy this module from some module vendor in China, Taiwan, someplace like that, and though they will supply a very generic module that is can be used for many applications, right? So then they come and bring and stick in that module into their product, and they do some basic integration testing, and they start selling it, right? And that is not enough, but that was never really an issue because the feature really never got used in any of the products that they sold. But that is changing now with the modern day. People are using the Wi-Fi interface in the air conditioner. People are using the Wi-Fi interface in the garage door opener, in the doorbells, and in fact they're using it very extensively. We have vacuum cleaners that use Wi-Fi. All our TVs are on Wi-Fi now. Same thing happened with the TVs. So the early version of Wi-Fi radios inside TVs, people never really used them because you are still connecting to the cable TV through a wired connection. You're connecting through Ethernet, but now that's all gone with ODT. TVs don't have wires anymore other than the power cable, right? So everything runs over Wi-Fi, and if it doesn't work, it creates a lot of problems. So because of all these trends, now testing of station devices becomes extremely important because they're running mission critical applications in all these various kinds of markets that I've talked about. Retail environment, they're running mission critical applications. Healthcare, they're running mission critical applications, and many industries, industrial IoT sector. So they're running all these kinds of very mission critical applications where the connectivity is very important, right? And most of us, when we are sitting at home, we are using all these apps, Instagram, WhatsApp. We are doing all kinds of like stock trading. We're doing various applications that run on the mobile phones, and for every one of them, connectivity is important, right? So that makes testing of station devices ever more so important than it was before, right?
Absolutely. And as you mentioned, the modules that are being put out to the customers with just basic testing, and now people started using it, but this could lead to issues in field, as you mentioned. So I agree that station testing is absolutely becoming important these days. And talking about issues, let's say if one of my station device is unable to connect to an access point, whom should I blame? Should I blame the station device or should I blame the access point?
Yeah, that's a very political question, I guess. So if you're making the station, then you blame the access point. If you're making the access point, then you blame the station. But jokes apart, yeah, the problem could be with the station or with the AP or with the interoperability between the AP and the station. It could be anywhere, right? So normally that is the reason why Wi-Fi standards exist, because we have Wi-Fi routers that are made by many different companies, and they have various implementations, and then stations devices are also created, designed, and developed by many different companies, and we need to make sure that all stations interoperate with all Wi-Fi routers, and that's what the standards are there for, to make sure that there is strong interoperability. And there are organizations like Wi-Fi Alliance that has certification programs that will try to test to make sure that the station is interoperable with an access point. But having said that, not all implementations follow the spec, and there are some gray areas in the spec, and so people kind of have their own implementations, and because of that, there is always interoperability issues and connectivity issues. So if a station is not able to connect to an access point, it could be because there is some form of incompatibility between the AP or the station. It could be that the station is not following the spec. It could be the AP is not following the spec. Many times it needs some detailed analysis and debugging. So in our testing world, when this happens, we try to isolate the problem. So let's say if a station is not connecting to an access point, we'll say, okay, fine, let me change the access point and maybe use a golden access point that is generally known to be good, and see if I still have the issue. If I don't have the issue, then it's most likely the AP's problem. If I still have the issue, most likely it's a station problem. So we try to isolate the problem, and then we try to figure out where exactly the issue is when we do the testing. But to answer your question, it could be either one of them.
Yeah, it depends, I think, right? Right. This question comes from my personal testing experience. So over the past few years, I have been running benchmark testing, throughput benchmark testing of access points, how well it can handle the data. And most of this testing is done using emulated virtual clients. They are not real clients, so they are virtual clients. But for the past few months or so, I'm also trying to get hands-on with real devices, and the behavior that I see, the performance numbers that I see are quite different from what I saw from the virtual stations. And the numbers are most often times they are comparatively lesser by what we are achieving with virtual clients. So is there any reasons? I mean, there could be multiple reasons, but I would like to hear from you on what are the potential reasons that is causing the lesser throughput numbers with real devices.
Right. So when we use test equipment, the test equipment is used for convenience reasons. So the idea is like if you have a box that emulates hundreds of virtual devices, the reason why we do that is we don't want to test with hundreds of real devices. It takes a lot of space, time. You cannot automate the testing. It's not repeatable. And so rather than having 100 real devices, we use a box that can emulate hundreds of virtual devices. Now, when we test in that environment, the idea is to really test under ideal conditions, and we have to realize that when we create 100 virtual stations in a box, they're all mostly behaving the same way. They're sharing a same radio on the box. They're sharing the system resources that are predefined and well defined. So we normally, when we have test equipment, we have very high end systems with a really good CPU, memory, processing capabilities, and so on. So these are high end machines that don't have any compute problem or processing issues, right? So now they're sharing a common radio and they're transmitting. And normally test equipment, if you have like 20-30 clients, they're all trying to connect to the router access point and send traffic. Test equipment generally schedules the traffic because it's a single radio. You have to remember that even though we created 20-30 clients, we're using one shared radio. And so the test equipment generally tries to schedule traffic, and it makes it very deterministic, right? But that's not how the real world works. If you have 20-30 devices in a house and they're all trying to connect to the Wi-Fi router and send traffic, they're all at different distances. They're all using different Wi-Fi protocols, different standards. They're all contending for the medium. So there's real medium access contention where everyone is waiting for their turn before they transmit. And so that creates some overhead in the real network. We have to remember that every device that we are using is of a different form factor. It has its own system capabilities. It has its own CPU limitations, memory processing limitations, and so on. It has its operating system related limitations. Some operating system might impose certain restrictions on the Wi-Fi performance possibly, and different versions of software might implement it in different ways. So there's all these variables that come, different radios, different chipsets, different distances, different processing power, different operating systems, and different ways in which they do QoS, different ways in which they do medium access. So once you throw in all these variables into the setup, of course the testing will not give you the ideal results like you would get in the case of test equipment. But the testing results are a lot more realistic and closer to what happens in the real world, right? So there are advantages and disadvantages. When you test in the lab, your testing is a lot more deterministic, a lot more repeatable, but not as realistic. When you test in with real devices, it's a lot more realistic, but not automatable, not repeatable, and the results can vary a lot, basically, right? So
Right. Each side has their own pros and cons. You mentioned there could be challenges when testing real devices. So could you elaborate a little bit more on what kind of challenges do you generally face when testing with real devices?
first of all, when we set up these test beds, and we have been doing that a lot in our organization, at least over the past, I would say 1 or 2 years now almost. And the idea is, okay, if you're trying to recreate the environment of a home, we want to have a typical home now has 20, 30, 40 devices of different kinds. So we want to recreate that home environment in the lab. So what we'll have to do is we'll have to basically get all these devices and set them up. So first of all, setting up the devices, making sure they're always using the latest version of operating system and things like that, making sure they're connected and powered up properly itself is a challenge. It needs a lot of space. And normally some of the very practical issues we have is when you power these devices on and run like a really long duration test. And that means that the device, like a smartphone, is constantly powered, and it sometimes can damage the battery and things like that. You'll see battery bulge issues on these devices. We have seen that consistently. Sometimes because of OS interrupts or some updates that are happening in the system that could turn on or turn off the radio interface, that could put the device to sleep. And it's not easy to kind of know what these devices are doing. It's a lot harder to automate the devices also. When you're using virtual devices, everything is automated. Here, you have to check what each operating system, every operating system is different. The way you actually control these devices, the way you actually configure them, the way you run any kind of tests on them, the way you gather results is all a lot more complicated and very different when compared to what we do with the virtual devices.
Right. And I believe it gets even more challenging, I guess, with the very specific application devices that you have mentioned, right? Because they are designed for very specific things, and they might not even have that enough compute or hardware resources, right? Is it particularly more challenging with such kind of devices?
Yeah. So when it comes to testing, if you take a general purpose device like a smartphone or a tablet or even a VR headset, or we have done this with VR headsets also, we can actually install some form of an agent software and endpoint software on the device that allows us to control the device through automation. So that makes our life a little bit easier.
Right.
But if you take, let's say, VR glasses that you have, or maybe like a light bulb, or maybe even a security camera or a surveillance camera or a doorbell, these are type of devices that don't really have the ability for us to install any software on them, and they don't really have any physical interfaces also other than the Wi-Fi interface. So provisioning them, controlling them, configuring them, and running meaningful tests on them makes it very hard. So for example, when we test, let's say a video doorbell or some form of a video streaming device, like a wireless camera, normally what we'll have to do is we'll have to put it inside a piece of test RF enclosure, and we need to play some form of video in front of it. Maybe we need to have some form of robotic arm that actually moves it, the device to trigger motion sensing and so on. So there is all these tricks that we'll have to use because we cannot automate the device through software. So we'll have to automate the device, the testing of the device, to some form of external gestures, right? It's like the way real users would use them, right? And these are all the challenges that are there as a part of the testing.
So now, given the challenges and also given the variety of devices that are coming online these days, how do we create a test plan to test all these devices, and what are the kind of test cases that I should include in the test plan?
Right. So I would say, given the diversity of all the Wi-Fi station devices that we have, I would broadly classify the testing of Wi-Fi station devices into two categories. One is the kind of the basic benchmarking piece, where you want to make sure whatever is common across all the Wi-Fi devices, station devices, that common elements are working properly. So for example, every Wi-Fi station device, no matter what type of station it is, it has, again, as I said, a transmitter and a receiver, right? It is supposed to connect to a particular router. It has supposed to be able to send and receive data. So this is basic testing. So connectivity, benchmarking the performance of a radio, a transmitter, receiver. These are common test cases that you have to run for any kind of station device,
Irrespective of the device.
irrespective of the device, right? Now, sometimes if as I mentioned, previously mentioned, sometimes getting access to these settings is easier for some devices. It's not easy with other devices. But this is a common problem that any device has. Even it could be a doorbell, or even an asset tracking, or even a sprinkler system, or it could be a light bulb that runs on Wi-Fi. The transmitter and receiver has to work well, and you need to be able to perform well over distance. All these things we need to do, right? So performance over distance, radio characteristics, transmitter receiver performance with in the presence of interference, basic throughput, basic connectivity. These are common set of tests that are run for all kinds of station devices that you see. And then there are the application specific user experience based test. Now this test plan will change a lot based on the type of device. Let's say you're testing a smartphone. So of course you want to test the smartphone to make sure you can browse you can connect to YouTube, you can do a Zoom call, a Teams call, WhatsApp call, you can do Instagram Reels. You should be able to do a number of different applications that you traditionally do on a smartphone. And you need to make sure all these applications are working on a smartphone while you're mobile, because you're mobile with the smartphone. So if you're living in a large house, you might be, or even an office, you might be moving from one part of the house to the other, which means that you're handing off from, if you have a mesh network in your house, from one node to the other node. And while you're handing off, you're carrying a WhatsApp call, and you're basically doing, let's say, watching a movie on Netflix or something. You need to be able to seamlessly move between one device to one router to the other router without any interruption, service interruption. So roaming, range testing, and things like that are extremely important. And for mobile devices, testing for power save and battery power are also extremely important. Tolerance to interference is important, right? Now, if you're building applications let's say the station is a VR headset, right? So then latency becomes very, very important, because you're doing some real-time online gaming, and you cannot lag. So lag is not an option. So you could have, it's not just about bandwidth, it's about latency also. So that becomes important for that application. We talked about medical equipment. Okay, constant connectivity becomes a very important aspect, right? If you talk about a wireless printer or a scanner, so they are moving around on the shop floor everywhere. So if you have a small handheld wireless printer, normally people are holding it and moving everywhere in the facility, and they can go very far from the Wi-Fi router. So then performance over distance becomes important. If you have a surveillance camera, normally you put the surveillance camera in the front of the house or the back of the house. So it is the farthest from the Wi-Fi router. So you need to make sure that you get the range, right? Security becomes important based on the type of device. If you're using a surveillance camera or any kind of device that can cause security breaches, so security becomes very important. You need to test to make sure the connectivity is extremely secure, right? And so you want to make sure you're using the most advanced security protocols. So all of these things, the test plan kind of changes based on the type of device and the application that you're using. So what I'm trying to say is there are a constant set of tests that are common for any type of station in the world, and then on top of it there is so many different variants that you need to create based on the use case of the application. So normally when we do testing, we write individual test plans for different types of station. If you're testing a wireless refrigerator, there's a test plan. If you're testing a doorbell, there's a test plan. If you're testing a security camera, there is a test plan, right? If you're testing some printer, there is a test plan based on the applications. So that's what makes this very interesting.
Right. So so the test cases are totally device specific, but there are some test cases that you cannot escape. They have to be performed irrespective of the device to ensure good user experience over Wi-Fi. Now, few devices, like let's take mobile phone. It has multiple wireless interfaces, right? It has Bluetooth, it might have NFC, it has cellular, and it also has Wi-Fi. So with all these wireless technologies that are present on the device, how important is Wi-Fi to the mobile phone in terms of connectivity or whatever the user is doing? And also I'd like to extend this question because in today's smart home scenario, lots of devices are coming online. Is Wi-Fi the key technology that is gluing all of them together? If yes, may I know why?
Yeah. And so early on in my career, I would spend most of my time testing Wi-Fi routers and access points, and there we would really geek out on the technology, and we do so many different types of testing and things like that. But when we came to smartphones, I always used to wonder, why are these large companies that make these smartphones not spending the same amount of time on Wi-Fi testing as a company that's making a Wi-Fi router, right? This is a question that I always used to have. And then over a period of time, I realized that for a smartphone, if you take a Wi-Fi router, Wi-Fi is everything in the Wi-Fi router. It's 100% of the Wi-Fi router when it comes to technology goes.
Absolutely.
But if you take a smartphone, Wi-Fi is only a small portion of the technology of a smartphone. Smartphones have displays, processor systems. They have many different types of radios. They have many different types of use cases. They're used for many things. They're used to make a phone call. They're used to do many other things other than just connectivity over Wi-Fi, right? So early on, this is how it used to be. Wi-Fi was a very small portion. Most of the data and communication connectivity was still done over cellular with smartphones and devices like that. But that changed a lot over the years. So now, even though these devices have all these different types of interfaces which are used at different times, the Wi-Fi interface is still the most predominantly used interface. And that's if you go and look at your smartphone and look at your daily stats of how the smartphone is used, and it will tell you how much time you use your Wi-Fi interface, how much you use the cellular interface, and so on. And you would see your device is predominantly being using the Wi-Fi radios and Wi-Fi interface, and that's what really changed things when it comes to the need for testing with all these devices. And you had a follow-up question. So
Yeah, the follow-up question was, with the growing smart home scenarios that we are seeing today, more and more devices are coming online. And is it the Wi-Fi technology that is gluing all of them together to exist in a smart home scenario where the user can control multiple devices or provision them? Is Wi-Fi the dominant technology there?
Absolutely. So there are, if you look at a home or anywhere which is indoors, which is not which is fixed wireless indoors or even outdoors. Actually, to be frank, only the mobile wireless use case, which is when you're traveling at 100 kilometers per hour, 50 kilometers per hour speed on the highway, or you're traveling with train or things like that, then of course cellular is the only option that you have. But if you have any fixed wireless case, indoor or outdoor, Wi-Fi is by far the most predominant technology that is being used right now, right? So in many ways, that is absolutely, that's the most important technology that's being used right now.
Right. Now, since you have lots of experience in this Wi-Fi testing area, I'd like to know if there is any test plan that is designed for evaluating Wi-Fi station devices. Like we have, for instance, for testing access points, there are few test plans, right? TR390, there is one test plan to evaluate your access point performance. Is there a test plan existing to evaluate Wi-Fi stations, or do you think, if not, do you think there should be one?
Certainly there should be one. I think there should be an industry standard test plan. It will get there at some point. Right now it's not there because there is it's not the Wi-Fi testing for stations is not very coordinated, and everyone is doing their own thing and based on their use cases. And as I said before, an access point is fairly deterministic in what it does, but a station has many different applications. So it's very hard to write a common test plan that can be used for many different types of stations. Now, but with the increasing explosion of the number of Wi-Fi stations that we have, and the applications and the demand for testing and things like that, it's only a matter of time before we actually start writing very standardized test plans for testing different types of station devices. There could be a standardized test plan for testing a smartphone. There could be a standardized test plan for testing a medical device, and so on, and based on the applications and the use cases. And that's very much possible. And I certainly think that there's a need for that because of the mission critical nature of Wi-Fi.
So you see, it could be happening in the future.
Absolutely.
Right.
Yep.
Yeah. So that's all for today's episode. Thank you so much, Mr. Sitarama, for sharing your valuable insights. And I certainly learned a lot. I think there are a few eye openers for me when you categorized the kind of stations and how one should approach testing a station device. And I hope you audience also found this useful. If you are learning what factors could affect the wireless experience of users. It's not just the access point or the medium, it's equally important that testing station devices, right? Because that's where the end user lives. That's where he presses the button, that's where he toggles or whatever, right? So thank you so much for your time. I hope you found the session useful, and if you do, please like, share, subscribe, and if you have any questions, please leave them in the comments below, and we'll meet you soon in the upcoming episodes. Thank you for your time.
Thank you, Sana.